Hello students, welcome back to our class. We were discussing periodic table lesson and in that we were discussing general trends of the modern periodic table. Now we are going to discuss some of the characteristics of the periodic table in terms of specific groups. So one by one we will be dealing and picking up the groups from the periodic table and will understand all the information about that particular group. So let's start the session and we have a study of specific groups including group 1 first, that is alkali metals. The elements of group 1 are your, do remember them, lithium, sodium, potassium, rubidium, cesium and francium. Francium is the radioactive element. So the last element of each group is radioactive. That is also one of the characteristics. The elements are these and they have one electron in their outermost orbit and therefore they show one valency. Because they are one electron less, they are actually one electron more in order to become stable. So they lose their one electron to become stable. So they are placed in 1A group, the first column on the left side of the periodic table. They are known as alkali metals as they react with water to form hydroxides, that is bases, and those bases which are capable of dissolving in water are termed as alkali. So that is why they are considered as basic in nature also. They form strong alkalis, bases soluble in water. For example, according to this reaction, a metal when reacts with water will form a hydroxide MOH plus hydrogen gas is liberated, where M is any metal of 1A group. Characteristics, then first we'll talk about configuration. So these are the group 1 elements and their configuration will be written according to the rule which you have learned, that is 2,1 for lithium, 281 for sodium. Then similarly, so you can understand here that 1 is the valence electron in all the elements of group 1 and group signifies the number of valence electrons in a group. I am repeating this again and again so that it can set in your mind. Occurrence, all of them are very reactive and they do not occur in free state because they are highly reactive. One electron is present in outermost shell, so they can easily lose that electron to become connected with any other element. So that's why they are very reactive. Nature, they are soft, they can be cut with a knife, sodium, potassium are the examples, and they have low melting and boiling points. Bonding, they form salts except some salts of lithium, all are ionic. Some salts of lithium are covalent in nature. We have learnt about electrovalent and covalent term in your chemical bonding lesson. So now you are able to relate this thing. Alkali metals being highly reactive, they lose their electrons completely and they give electrons to non-metals. So that is why they are forming salts of ionic in nature. Action of air, they react rapidly with oxygen and water vapor in the air according to this reaction. So when they react with oxygen, for example sodium, it will form its oxide according to the valency. So do remember, you do not need to learn then mug up, because if you remember valency symbol of the element, you will definitely be able to complete the reaction. And similarly, when oxides of group elements are dissolved in water, they form alkalis, right? And these alkalis, when react with carbon dioxide, any other gases are present in the atmosphere, will form sodium carbonate in this case, that means metal carbonates and water are formed. Here they are showing typical neutralization effect because we said that these are basic in nature. We know it is a base, right? Carbon dioxide is a non-metallic oxide. Metallic oxides are basic in nature, so obviously non-metallic oxides are acidic in nature. So when an acid and base is reacted, so salt and water is formed, which is a typical neutralization reaction. Reactivity of these metals increases down a group. Action of water, they react violently with water to form their respective alkalis and hydrogen gas is liberated. Action of acids, when a metal of group 1 reacts with an acid, it forms respective salt and hydrogen gas is liberated. These you need to remember very well, that alkali metals, there is a reactivity series of elements, okay, in which alkali metals are present at the top and hydrogen is placed in between somewhere after your zinc, iron and all that, okay, and it is above copper. So that reactivity series indicates the elements present at the top are highly reactive, the ones which are present at the bottom are least reactive. So these metals are above hydrogen, so they will show displacement reaction. We have learned this in chemical reaction lesson, right? So that is why they displace hydrogen from their salt and attaches themselves, and H is released as H2. Okay, so that's how it will be easy to understand this reaction and remember also. They form unipositive ions easily. Unipositive ions because they lose electrons minus E, right? So they will form M+1. They are strong reducing agents because they are providing electrons to someone else to get reduced. To form, by reduce we mean there will be no charge on that particular species. Plus minus. When freshly cut, they show typical silvery white metallic luster. They are metal, so they are lustrous in nature, we know this. But soon they turn dull, tarnished because of oxidation, because they come in contact with the atmospheric oxygen and oxidation takes place. All alkali metal salts, they impart color to the flame, like sodium, it imparts golden color. Potassium, it imparts lilac color, whereas lithium, crimson red. Okay. Alkali metals are obtained by electrolysis of their molten salts like NaCl, LiCl in this manner. Then group 2 alkali earth metals, they are known as alkaline earth metals, right? Their members are from beryllium, magnesium, calcium, strontium, barium and radium. These are the elements which are known as alkaline earth metals because their oxides, they occur in the earth crust. They are found in the earth deposit, that's why they are alkaline earth metals, and their hydroxides are weak alkalis. In comparison to group 1, they are less basic because left to right basic character decreases, that we know very well. All the elements of this group, they have 2 electrons in their outermost orbit because group 2, and they show the valency 2 because 2 is easily to lose and become stable. So they are placed in 2A of the periodic table. Characteristics, first electronic configuration. So from beryllium to till radium, you can see 2 is the outermost electron present. So that's how you write their electronic configuration. Occurrence, they are reactive metals, less reactive than alkali ones. They do not occur in free state. They are also reactive in comparison to other members of the periodic table in nature. So they are grayish white in color. They are harder than the alkali metals. All the alkaline earth metal salts except beryllium, they are ionic in nature. So the first member of the group is usually, of these groups 1 and 2 are covalent in nature, okay, because of extremely small size. That is the reason. That concept will be dealt in detail, that why they are covalent, in your higher class. But till here you just need to remember the nature. In higher class we will introduce the concept of Fazan rules to explain covalency. Action of air, they are less reactive than alkali metals. Their reactivity increases on moving down a group, the same concept that applies to alkali metals. Action of water, they also react with water to form their respective hydroxides according to the valency, and hydrogen gas is liberated. They are also found above hydrogen, so they easily replace hydrogen from their substance. Action of acids, they also react with acids to liberate salt and hydrogen gas according to the valency. They form dipositive ions because they are losing 2 electrons, so M2 plus type of cations are formed. They are also strong reducing agents. Melting point, boiling points are comparatively low, but these are higher than your alkali metals. Except beryllium and magnesium, all other alkaline earth metals, they impart color to the flame. Like calcium, it imparts brick red color, strontium crimson color, barium apple green and radium crimson. They are obtained by the electrolysis of molten salts. So some of the characteristics are similar to that of alkali metals only. Then next specific group we have group 17, which is the halogen family, or group 7A is also written in this way. Their members are your fluorine, chlorine, bromine, iodine and astatine. Halogens, the Greek meaning salt formers. So they are actually existing in the form of salts because they form salts easily, so they are known as halogens. It is A here, okay. The name halogens, Greek halos, sea saltogens, producing meaning sea salt former. Their elements have 7 valence electron according to this chart, and they are most reactive non-metals. So among non-metals, they are most reactive because reactivity of non-metals increases left to right, and they are present extreme right, okay, before group 18. Group 18 has special characteristic that we will not consider with these elements. So obviously we are left with group 17, and they are typical non-metals. They show high reactivity also because of their one electron less in order to become stable. So they gain that one electron in order to become stable easily. Their reactivity decreases down the group because size increases. For example, fluorine is the most reactive, iodine is the least reactive. There is steady increase in the melting point and boiling point as we go down a group. Fluorine is a gas, chlorine is a gas, bromine is liquid, and iodine is a solid. So what happens that on coming down a group, because mass is increasing, the van der Waals forces existing between the atoms is going to increase, which causes transition of physical state from gas to solid in these halogens. Astatine is highly radioactive and a rare element. The last element is radioactive, we know this very well. And the intensity of the color of element also increases from light to dark on coming down a group. Fluorine is pale yellow gas, chlorine is greenish yellow gas, bromine is reddish brown liquid, and iodine is a violet solid. Bromine is the only element which is liquid at room temperature among non-metals. And non-metals do show all the physical state, that is solid, liquid and gas, but most of them are gaseous in nature, few are solids, and only bromine is liquid. They are all poisonous. They have similar strong, pungent and unpleasant odor, suffocating odor, and they all form diatomic molecules because they are one electron less in order to become stable. They show covalent bonding, so they exist as diatomic, F2Cl2I2Br2. They all have, and they are gaseous in nature, these diatomic molecules. They all have valency 1 and they form compounds with similar formula like HCl, HBr, Hi, HF in this manner. They produce a series of compounds with other elements, chlorides, bromides, iodides. In together they are known as halides because from halogen the term is taken. The halogens themselves can react directly with metals to form metal halides, which are nothing but your salts only, like NaCl, NaBr, these are salts, right? They all form negative ions carrying a single charge, fluoride ions F minus, Cl minus, Br minus, I minus, because they are gaining one electron to become stable. Then the next specific group we have group 18 or noble gases, or group 0 also. Group 0 because they have zero valency, noble because they have less reactivity towards the elements like oxygen and fluorine. They are not now considered as inert, but the term inert meaning because they were having stable configuration, so they were not showing any reactivity. But we know now, I have told you just, we will deal with this concept in detail in higher class, that they show reactivity because they have similar ionization enthalpy. That concept will be also dealt ahead. When Mendeleev first constructed his table, there was no indication that a whole group of elements, group 0, remained to be discovered. Mendeleev was not aware that noble gases are going to be discovered. Because of their lack of reactivity, there was no clear sign of their existence. Their percentage is also very less in the atmosphere and they are very less reactive, so it was not easy to identify or discover them. However, analysis of the gases in air, they led to the discovery of argon. Argon was the one which was first discovered. Helium was first detected by spectroscopy of light from the sun during an eclipse, and the other noble gases were then isolated. The credit for discovery of these gases goes to William Ramsay. He was awarded Nobel Prize for this major contribution. These gases, helium, neon, argon, krypton, xenon and radon, these are referred as inert gases, meaning they do not react at all. In 1960s, some compounds of xenon and krypton have been made, XeF6, XeF2, these types of compounds, and their name was then changed to noble gases because they are not completely unreactive. They do show some reactivity, that's why they are considered less reactive. And in 1960s, by the work of Neil Barter, was able to extract compounds of these noble gases, specifically xenon and krypton. Characteristics: their configuration have 8 valence electrons except the helium, which has duplet configuration. Helium has 2 in its shell, all other have 8 valence electrons. Their electronic arrangement is very stable, so they are unreactive. All are colorless, tasteless, odorless gases. They are neither inflammable nor supporter of combustion. They are monoatomic because they do not show reactivity, right? Because their configuration is also stable. Noble gases are liquefied with great difficulty These gases are slightly soluble in water, and moving from helium to radon, solubility will increase because size is increasing. These gases, they emit colored light when an electric discharge is passed through them. They show fluorescence also. Their melting points and boiling points are extremely low. Helium has lowest and cannot be solidified by cooling alone. Pressure is needed. All these properties point to the atoms of noble gases being particularly stable. The uses of noble gases depend on their unreactive nature. Helium is used in airships and balloons because they are unreactive, so they are used in places where reactivity is not required because it is both light and unreactive, so it will not be causing combustion. Argon is used to fill light bulbs because it will not react with the filament tungsten at high temperature. The best known use of the noble gases perhaps its use in neon lights. The brightly colored advertising light works when an electric discharge is passed in a tube containing a little of a noble gas. Different gases impart different colors. The elements of group 0, that is 18, are between the two most reactive groups of the element, that is group 1 and group 17. Indeed, it is their closeness to these groups with the stable configurations that makes alkali and halogen so reactive. They can easily achieve noble gas electron structure. The group 7a also, that is 17, gain 1a to achieve the stable configuration just like noble gases. So while 1a loses the electron, whereas 7a will gain the electron. Elements of group 18 are between two most reactive groups of the element. We have discussed this factor, right? They can easily achieve noble gas configuration also. Periodic table uses now, what is the significance? We are going to discuss. It has been useful in predicting the existence of new elements. It has been useful in the past in correcting the properties of elements. Study of elements and their compounds has become systematic and easier to remember by the development of this periodic table. Position of elements in the periodic table reveals their atomic number, their configuration, number of valence electrons, properties. So many characteristics or information about an element can be deduced by studying this periodic table. And we have discussed the general trends also. So it is one of the important contribution or discovery or invention, you can also say, development by several scientists who made the study of elements easy. And we know these elements are very important, significant to us in our daily life because they constitute and are being used in development of several molecules. Nature of chemical bond, formula of compound formed and properties of that compound can all be predicted from the periodic table. Like elements present in group 1, 2, 3 are metals. They lose electron to form positive ions. While elements of group 15, 16, 17, they are non-metals. They gain electrons to form negative ions. When these positive and negative ions combine, they will form a compound known as SOR and they give rise to electrovalent nature of that compound. If elements of group 14, 15, 16, 17 combine with those of 15, 16, 17, they are non-metals only. Where non-metals are combining with the non-metals they are known as covalent compounds. The bonding part we have already discussed. Position of element in the periodic table. In the periodic table reveals valency also, whether element is metal or non-metal. Occupy extreme left position, those metals, and at the bottom of the periodic table, while non-metals are at the extreme right of the periodic table. So with this we will wind up the session where we have covered all the concepts related to the periodic table, general trends of elements in the periodic table, that is ongoing across a period left to right and on coming down a group from top to bottom. So do remember all the concepts. Important questions are framed from this lesson and this lesson itself is very scoring. So we'll meet again with another interesting lesson in our next session. Thank you so much.